Hi everyone, this is your struggling senior student. Welcome back, and today let's solve another LeetCode problem. So let's take a look at today's problem of the day, 2381 shifting letters 2. We're given a string S of lowercase English letters and a 2D integer array shift, so shifts of I is start and direction. Okay. For every I shift, the characters in S from the index start to the index end inclusive, or for every index I, you shift the characters in S from the index start to the index end, inclusive forward if direction is 1. Shift the characters backwards if the direction is 0. Shifting a character forward means replacing it with the next letter in the alphabet, wrapping around so that Z becomes A. Similarly, shifting a character backwards means replacing it with the previous letter in the alphabet, so wrapping around so that A becomes Z. Okay, return the final string after all such shifts are applied. Okay, so you have these shifts. So from 0 to index 1, inclusive? Oh, inclusive, okay. So firstly, you shift the characters from index 0 to index 1, then you shift the characters from index 1 to index 2, forward. Okay, so you just shift it by 1, right? Just shift it by 1. From index 0 to index 1 backwards. Why does C become... Wait, what? So for every I, you shift... For every I, shift the characters in S from the index start to the index inclusive forward, or shift the characters backwards. Okay, I'm a little bit confused because if you shift from 0 index... Oh, okay. I was looking at the wrong one. I thought this was the input. Okay, sorry. So you shift A backwards once, so A becomes Z. Then you shift B backwards once, so B becomes A. C remains unshift, remains what the remains where it is. Then you shift index 1 to index 2 forward once. So A becomes B and C becomes D. And finally, you shift the characters from index 0 to index 2 forward once. So Z becomes A, B becomes C, and D becomes E. Okay. Okay, let's take a look at example 2. Okay, example 2, DZ T0, index 0 to index 0 with shift of 1, so shift this back once. Then index 1 to index 1, you shift forward once. So Z becomes A, right? So let's take a look at the constraints. So S dot length shift dot length is 5 to 10 power 4, etc., etc. Okay. So if we have been, I think there was another version of the problem which is shifting letters 1, also from a few days ago. Was it? Oh, never mind. Never mind. But the idea is essentially you use a prefix sum, you compute the final shift or the net shifts for all of the shift movements that you did. So what I mean to say is, what you can do is you can combine all of the shift and compute the final displacement of each of the characters in S. And as long as you do that, then you're done. That's essentially the idea. Oh, okay, I remember now. It's a weekly premium problem, right? Yeah, perform string shifts. So in the editorial that we took a look at in the video that I did a few days ago, one of the solutions that they did was to actually compute the final displacement of each of the characters by pre-processing shifts. So I think we can do just that. So we can do final shift is equals to, let's say 0 times length of S, or maybe let's just do N. So N is equals to length of S. And from here, we can compute the final shift for each of the characters in S. So we will say for start, end, and direction, we can say backwards is equals to 0, forwards is equals to 1. These are the constants to represent the direction. So it makes the code a little bit easier to read. So if direction is equals to backwards, we do something else, we do something else. So if the direction is backwards, then what we can do is from start to end. Oh, wait, hold on a second. Shifts of I, shift dot length is start and end. Start and end. It's up to s dot length. Okay, so if we keep iterating through it like this could be a problem, kind of. This could be a problem. Okay, I was initially thinking of like for, let's say, up or shift range of start to n plus 1, we do something like final shift I plus equals 1, right? But the worst case is if, let's say, start and end is always the maximal case where right, it's always up to s dot length, then it's easy to construct an n square case. In this case, I'm thinking of something to do with straight line instead, straight line algorithm. I'm not sure if it will work, but let's go through an example. Right, let's go through an example. That means what? At this interval, so we can think of interval, so we have 0, 1, 0, 1, then 1, 2, then 0 to 2, right? So 0, 1, this point, inclusive, yeah, maybe I can draw them like this, black dotted, inclusive. 0 means what? 0 means we're shifting backwards. So you can think of it as like a straight line algorithm where we encounter backwards. When we encounter a backwards interval, then we have to deduct it by 1. Deduct it by 1. What's in a range though? It's in a range. Okay, let's watch on a bit. So at this point, this is -1, this is +1, and then you have 0 to 2, which is +1. 0 to 2, which is +1. Yeah. Not sure if we can just process it like this. So we process this first. What would that look like? Then we process this first. Then we process this. Then we process this. Then we process this. Then process this and process this. Okay, a little bit stuck, but we can try to see how the straight line algorithm can help us. This means what? Once we enter this interval, it means, well, there's no change for this character at least. Do we have its index? Yeah, we don't really have the index information. That's the problem, right? That's the problem. Wait a second. Maybe it will work. So basically, once we enter into interval, right, we always have the start point. And then we can get the event type, which means to say whether it's -1 or +1. And then we can compute the final shift for each index. I think that could work. So for start and direction in shifts, you can do events.append the start, then the direction, or what we can do is we can append 1 if direction is forwards, else 0. Okay, events.append. Okay, what if it's like this? Does it matter if we process one before the other? Not really. We kind of want to process them both at the same time. Okay, so I guess we can just do this. Wait, hold on a second. So when we leave an interval, we need to reference the direction, right? Yeah. We need to reference the direction. Okay. So I guess we can say if direction is equal to forwards, else we do something else. So if it's forward, then we do events.append start of 1. That means when we enter into the interval, we want to increment, right? When we enter into let's say this start interval, we actually want to increment the character at index 0 by 1. And then when we leave the interval, events.append and of -1, right? Because once we leave the interval, and actually it's starting at the next index, so it's n+1. Then at the next interval, suppose there was an index 3 here, then at the character in index 3 does not need any shifts in this example, right? So we do n+1 because it's inclusive. So yeah, if we do n here like this, then what happens is once we reach this index, we were already -1 here, essentially losing like this part of the computation. So we do n+1 instead. Alright, if direction is backwards, what this means is when we enter into the interval, we actually want to do -1. And then when we exit the interval, we want to add it back. So n+1 of 1. Okay, so events.sort. Then now we do the sweep line algorithm. So for the interval, I guess. Oh, maybe we do need the event type. I guess. So the event type will be, it doesn't really matter which one we process first because it's always based on the interval itself. Okay, process this first or process this first, it doesn't really matter. So maybe we don't need the event type after all. So we can say maybe the index and the direction, I guess. For index direction in events, right? So if you say if direction, is it the direction? Let's say shifts instead. So we do still need to compute the final shift. In this case, compute the final shift. So if direction is equals to 1, we do something else, So if the direction is equals to 1, this means that the final shift at the index, we want to shift it by 1, else that means we want to wait, hold on a second. Let me just print the index that shifts. I feel like maybe this itself it's fine already. Yeah, I think this itself should be fine. Let's print out the final shifts and let's take a look. Print final shifts. And we have the resulting string, which we will build it later. Let's just take a look at the final shifts for every index. Oh, n plus 1. Oh, right. That means we need to do n plus 1. Final shifts. Oh, final shifts. We need to do n plus 1 because because the boundaries are inclusive, then we need to handle the case where n plus 1 is actually outside of bounds. So yeah, let's go again. Final shifts. So will be 2, 2, 1, 1. Is that right? Ooh, that doesn't look right at all. This is saying that this should be shifted by 2 positions, but obviously I'm expecting this to be 0. Let's print events. Yeah, index 0, minus 1. Oh my, it's not plus equals 1, it's plus equals shift. Okay. Oh, shifts. Okay, let's go look again. Right, so it's 0. So expect this to be moved 0 times. Expect C to move 1 time. Okay, but actually this should be 0, 1, 2. Okay, is my exit condition wrong somewhere? Let's see, my exit condition. We can take a look at events. Frame events. 0, minus 1. Okay. And 0 plus 1. Then at 1, 1. 1, 1. Index 1. You increment it by 1. At index 2, you increment it by 1. Okay. At index 3, you minus 1, minus 1. Okay, let's take a look. Some bug here. So at this point, direction is backwards. Start minus 1. And then you only, once you leave the interval, then you add the plus 1 back. Right? So 0, 1 here. 0, minus 1 is here. Then you have 1, 1, 1. 1, 1. Index 1. Oh, you add 1 here, okay. Then index 2, you add back the 1 here. From here. Okay, and index 3. Index 3, you minus 1, because you leave, and then you leave here. Huh. Do we somehow need to process this? It doesn't really make sense to me. Index 2 plus 1 plus 1 plus 1. The end point here. The end point here. Huh. 1, 2, 3. This one plus 1 plus 1, and then here plus 1. Right? Yeah. Minus 1. Index 3 minus 1 minus 1. 0, 1, 2. At index 2. Oh, okay. I get it now. Okay, sorry. You have to check the current cumulative cumulative shifts. So you don't just take the shifts there. What you need to do is you need to check the current cumulative shift, which is 0 in this case. And then you take current plus equal shifts. And then from here, you can just assign it. Here you can just assign it to current. And if you print it out now, 0, 1, 2. Okay, right. So it's always the current shift because as we accumulate, so you can think of it as this case when we draw like a line here. Here we accumulate one shift, but we also lose one shift. So in essence, we haven't moved at all. In this case, for index 1, we actually have one shift here, but we lose one shift here. So the shift is 1 in this case. At this point, because we have already exited this interval, then we need to handle the case where at this point we have we add back the shift that we deducted, and from there we add the, do we add any more shifts? No, you just add back you just add the one shift here, so you maintain the current shifts, which is 2, and then yeah, that's it. I think that's it, right? So now once you completed the final shifts, then you can just go through for shift and final shifts, then you can start append the shifts for the character. So let's say, what is it? S of we need to index and enumerate our final shapes, shift of I, then we somehow shift it, right? And then we also need to handle the case where we loop it back. We also have to handle the case that we loop it back. So how do we do that? It's like some sort of modulus operation. Is it only lowercase? Okay, if it's lowercase, then it's something like ORD, I think, ORD of shift I plus this mod ORD of A, I think. Can only concatenate shift of I, oh, it's actually like this, mod ORD of A, name the character here, like so, unmatched. Let's see, like this, okay, and we need like this. Wait, oh my days. So your ordinance of S of I plus shift, ordinance of I plus shift mod A. Really? Oh, I see. Because you want to exclude out the last one. You want to exclude out the last one when you handle the empty case. So I guess what we can do is final shift start hop. It's a little bit ugly, but okay, it's wrong still. Huh. I guess we can print this out. Is this wrong somehow? Print char of this. Wait, is it actually wrong? It's empty. Empty. Okay, let's take it one step at a time. ORD of shift of I plus shift. Okay, would this work? 97, 99, and 101. It looks correct. Then you take the chart of this now. Or rather, you take this, and then you mod ORD of A. Does that work? So it's 0, 1, 2, 0, 1, 2. Oh, that's the offset, right? So 0 is now character A, and then 2 is C. Yeah, okay. So now you take ORD of A plus this, then you get the, okay, and then you take the character of this. I feel like there's an easier way of doing this. Oh my god, yeah. Well, there's an easier way of doing this, but maybe I'm just not getting it. Oh shit, okay. Did I not do the shift properly? So let's say ZZZ 0, 1, 2, we want to shift it forward once, can do this, we should get backwards once. So let's take a look. Wait, hold on, did I not dupe the, oh, I didn't dupe the test case. God dang it. Alright, GGG. Ooh, maybe there's something wrong with the final shapes. Oh, that's not good. Let's take a look here. 1. Oh wait, there's something that's actually wrong. Let's see the events. Print events. We gain 1 here, and then it's 0, 0. Well, that's not good. Basically, the 1 needs to propagate all the way. One, 0, 0, 0. This correct? Minus 1, 0, 0, 0. If I propagate them, then this will look weird, wouldn't it? So when we enter into an interval, we add the shifts, and then when we exit that interval, we propagate the changes. Yeah. I can't just maintain a running sum. The problem here is that we only increment the index 0 once, but these are not being affected. Of course, we can always keep track of the current shifts that we have, right? 0, so no work is done. Here, there's 1 here currently. It's not impossible, but it's a little bit weird, I guess. So the way I'm thinking of is for I in range of length of final shifts, then we say if we are at the current index, so we need a pointer right now outside. J is equal to length, J is equal to 0. Then while I is equal to final shifts of J of 0, right? Then we do can track the current. We check the current. Current plus equal shifts. J plus equals 1. Then we move on like so. Equals current. That could work. It's not subscriptable. Final shifts of 0. of events current plus shifts that would be this index R range j plus equals n. Oh, maybe we don't need n plus 1 in this case. Oh, it's still R range. Oh, dang. Length of final shifts j is less than length of events, and let's take a look. 0, 1, 2. Let's see this one. Okay, now it's being propagated, so that's good. Yeah, not sure about this one yet. Take a look later. Alright, let's handle this case first. Alright. Okay. Do we? No, I don't think we want to do the pop, right? In this case, yeah, we don't want to do the pop. The rounding for this one worked, but the rounding for this one absolutely did not work. Holy. Oh no. Let's take a look. One, two, three. ORD of A. The shift is 1 forward. Huh. Did I do something wrong? What is this shift? This shift is 26. I really need to memorize this. 1, 2, 3. 1, 2, 3. You mod it by A. Let's say print ORD of A. 97. So 1, 2, 3 mod 97, I guess, which is actually what I already did. Then you get 26, right? 26. That would be A itself. I have to mod 26 again. That is quite wrong. 0 ORD of A plus this. You get 97. Or what is one? 1, 2, 1 looks correct. Maybe it looks correct. This looks correct. So you do this correct. Let me take this. That's probably an easier way to do this. Okay, also the sample test cases. Yeah, not the cleanest solve, but okay, let's shift it backwards then this time. Let's shift it backwards this time. Shift it backwards again, and then we shift it. It's 5, we shift it backwards again. It should work, I hope. Okay, I'm gonna go with this solution. So the idea here is of a sweep line algorithm and just keep track of the final shifts. So what is the time complexity here? The time complexity is actually n log n, or you can think of it as 2n log 2n, because we perform some sort of sorting here, and n is the number of shifts in the shifts input. So you have start and end, and then we are keeping track of the start and the ending indices in shapes, and we are sorting them based on their starting and ending points. And from here, we are keeping track of the current shapes for as we enter into each interval. Now you might think that this looks like a n square time complexity, but it isn't. And the reason for that is because for the entirety of this loop, we are only running through the events array once. So for the entirety of the outer loop, the inner loop only runs for n number of times. So what do I mean by that? So if let's say you have a shift array that's like this, and then you have your events array that's like this. So for each element, right, doesn't really matter. Let's do A, B, C, D, and we can do X, Y, Z, D, E, F, right? So it's not like for each element in shapes, right? And then this is our events. We are processing events again and again, right? Events is always ever increasing. And then we come here again, and then this might move or not, right? So for the entirety of the outer loop execution, we are only iterating for a maximum of on time in the inner for loop. And for the outer for loop, now that's just on. Here we're just building the result, which is also just on time. And so the space complexity here is on as well, because Python uses team sort, and team sort is kind of like a variant of merge sort and is an insertion sort. So that takes on time. That takes on space and n log n time. So the time complexity is n log n, and the space complexity here is on. So now I'm going to give this a submit. Oh no, got a wrong answer. That's bad. Looks kind of close, but not really. Looks kind of close, but not really. Okay, is there a bug somewhere? So if it's backwards, enter interval -1. Else when we exit the interval, we have to add +1 again. Huh. Let's take a look. Zero, 1, 2, 3, 4. 0, 1, 2, 3, 4. So they're expecting Q here. No, they're expecting X, but then I have Q here. Okay, drawing this out will be kind of a pain. But let's try to debug this code. So 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, from 4 to 8, we're going backwards. So from 4 to 8, we are going backwards. Let me see how this works. Just have a feeling. Okay, never mind. Okay, 4 to 4, go back again. It's just -1. 0, 1, 2, 3, 4. Should work though, should work, yeah. 2 to 4, so 2 to 4, -1. 2 to 4, -1 again. Okay. And 6 to 7 plus 1. 6 to 7 plus 1. Oh, this is going to be a long example. So maybe I draw it here. 6 to 7 plus 1. 2 to 2 plus 1. And then 0 to 2 plus 1. So I have 0 to 2 plus 1, 8 to 8 minus 1. So like this, minus 1. 1 to 3 plus 1. 1 to 3 plus 1. Use right here. 1 to 3 plus 1. So let's take a look at this point. At this point, we have, yeah, it's minus 4. I'm missing it somewhere. Minus 1, minus 1, 0, 1, 2, 3, 0, 1, 2, 3, 4, B. Well, let's take a look at the SQ table. B, 1, 2, 3, 4, X. But putting Q here, where the hell is Q? Q is so far away. Okay. Basically, this implementation has some errors, I think. So the code itself seems fine, just that I have trouble building this again. Oh my days. Okay, we can just return the empty sequence for now. Let's bring res. 94? What is this 94? ORD of shift of I plus shift mod ORD of A. Is it just mod 26? Is that how it works? Then here we can take the ORD of A plus this. Then we take the character of this. R. Oh my god, this is just hella wrong. Wait, what? Oh my days. How do I translate this? Come on, man. ORD. Okay, let's take a look at this. 18. 18. Hell no, bro. Final shifts. Minus 1, minus 1, minus 1. ORD plus shift mod. Yeah, I was kind of confident this is mod A, isn't it? But it's not mod A for some reason. 24. 24. How the hell use 24, man? One, two, one. This is just like that. Zero, one, two, three, four. Why is it like that? Okay, let's do it slowly. I'm quite confident isn't this correct? Or the ordinance of S of I plus shift. Okay. Mod A. But for some reason, that is just messed up. $94. What the heck? $98 minus 4. Then you mod it. So 94. Oh, 94 mod 97. I see. I see. Okay. Okay. So I guess you mod A first, then you add the shift, right? So you mod A first, then you add the shift, then you add ORD of A again, and then this whole thing, the character of this. Oh my god, this is horrendous. Oh my days. Let's take a look at this. One ORD of S of I mod A, it's 1. 0, 1, 2, 3, 4, yeah, plus shift, which is what? That is minus 3, oh, mod 26. That will give me the offset, right? 23 plus ORD of A, 120. Then if we get the character of this, please tell me it's X. It's now X. Let's try to use this instead. I feel like it's probably a way easy. Oh, here return dot join res. Oh hell no, bruh. What the hell? This is tripping me out, bro. Is this a forward movement that's wrong now? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my days. How is it possible? Shift quality of as of I plus shift. No, you don't add shift right here, right? You mod ORD of A first. What ORD of A first? So you get the offset. Once you get the offset, this whole thing, you add shift. Oh, this is getting kind of confusing. This whole thing, you add the shift to it. You add the shift to it. And now you have the shift offset. You have the shift offset. Then you add the character. You add A back, right? Shift it back. Then you print the character of this. But this is now screwed. What the hell? Why is it screwed? I see. This one is less than -3. -3. You don't take ORD of A? Unless you take this whole thing and then you mod it by 26. Let me take the character. Okay, that's not a pen. Okay, submit. Okay, I got accepted, but that took too much time to implement this. I need to remember how to do this. This is embarrassing, to be honest. This is embarrassing. Difference array. I thought of this before. I thought of this, but the idea is the same. Whether you're using a difference array or a straight line algorithm. Emotional damage. Yeah, this one was kind of, yeah. Anyway, yeah, segment trees are an advanced tool, which I personally also don't know. Let's take a look. Oh, this approach is more advanced. Well, let's take a look at the list. Oh yeah, these problems are freaking hard as fuck, man. Is that editorial? Oh, I don't even want to look at this. Brute force strip line plus priority queue, strip line plus 2 priority queues, union find, divide and conquer. Did they ever have a oh no, yeah, they didn't even have a whatever this is, right? Or like bandwidth tree or segment tree solution. But yeah, this one was a hard one because of this thing, which I guess now that I look at it, the old character minus A, do I ever have that? Mod 26. Mod 20. Oh, this is the minus A part. Plus shift. Oh, okay. That's a number of shifts. So like this, right? Mod 26. I think this is something I should memorize, to be honest. Yeah. Let's give it a submit. Yeah, I see. Okay. Okay. Yeah. Alright. Just gonna show the code here again. So it looks like this. And then it looks like this. And okay, thanks for watching. This has been a long one. Goodbye.